Hi everyone, welcome to our presentation. We are in the Applied Deep Learning track, and the topic that we chose for our project is climate change and environmental risk mitigation. We built a model to predict the risk of wildfires in California, and we hope that you enjoy our presentation. Our team name is DYADIC, which is made of the first letters of our names. Our amazing team mentor was Dorothy, and our team members are Yavestra, Averill, Camden, Iris, and Dev. Now we'll look at the problem that we're facing regarding these wildfires, what we wanted to accomplish, and the groups that we targeted to help. This map shows the prevalence of wildfires throughout the nation. As you can see, wildfires occur in many states, but the one that has been most in the news lately has been California, and this is for a reason. 5 of the 6 biggest wildfires in California state history have happened in 2020. These fires in California have burned an incredible and horrifying 6,500 square miles, an area larger than the entire state of Connecticut, just in the last year alone. And our teammate Averill, who lives in California, will tell you his story about wildfires.
As someone who has lived in California for most of his life, I can personally say that wildfires are an existential threat to society. Often viewed as a very rich, wealthy state from an economic, cultural, and social perspective, California has made a name for itself as it being the golden land of opportunity. In recent years, however, California has become known for something far more sinister: wildfires. Driven by a climate change and a vicious cycle of heat and drought, wildfires are becoming significantly more deadly and difficult to control. But it's not just California. Much of the Western US and the world beyond have become far too familiar with these horrific firestorms. For those who live farther away from the immediate flames, the outlook isn't completely clear either. Wildfire smoke, which has been tied to the cause of many deaths and other social issues, can sometimes spread thousands, sometimes millions of miles across the globe. To help combat this issue, we have developed a model that can identify the most likely cause of a fire occurring in a given area in California. While this certainly is not a fix for the climate crisis, it will help businesses and organizations identify what measures they can take to mitigate the likelihood of fires in a region.
So now that we've looked into the background, we should look into the user research aspect of the project. So here we can see that a majority of the candidates or the surveys of the anonymous surveys that we took are from the East Coast. And even though wildfires are more prone in the Southwest area or regions of America, we found some interesting answers. So looking at the results, it's clear to see that not many people understand what causes wildfires and what are the risks associated with wildfires, but would like something to help assist them. And when we asked users, would it be better as an app extension or on a website, it seemed pretty split. So now let's look into the market. What can we differentiate? So when you go to Google Play, 84%, after searching up the keyword wildfire, 84% of the apps track wildfires after they've happened. And similar with the Apple Store, 80% of the apps, when you search up the keyword wildfire, track wildfires after they've happened. So this means people who are driving to a certain area are saved, but people in that area are now victims. So what can we do to stop that? What makes us different? So we predict wildfire risk before the fire starts, not after. We use local weather conditions to monitor and report dynamic changes to wildfire risk. This way we can help firefighters preemptively stop environmentally caused fires, and we can help people prepare for wildfires. So viability, how can we ensure that our company is self-sustaining? When it comes to property owners and realtors, we give them this resource so that they can understand the risks associated with their properties and what future actions they need to do. This may include buying insurance and getting some emergency equipment. We also sell this information to insurance companies. This way they can target people that are more prone to be in a wildfire accident or people who are more prone to be wildfire victims. And lastly, we target the government. This way, the local government can help more effectively use their resources to protect people from fire damage. One of the government's tools, HAZUS, is a largely used tool, but that helps people in natural disasters, although it doesn't include wildfires. So we'd help implement wildfire protection with that largely used tool. So now let's talk about the model.
To begin with the model, we have to begin with our data set. And the origin of our data set is the state of California. So there's two main sources. There's a CAGO data set with 1,600 fires in it. That is public data that originated from the California Department of Forestry and Fire Protection. And then there's another system from the California Department of Water Resources, the California Irrigation Management Information System, which is a collection of 150 weather stations throughout the state of California that provides monthly and daily weather statistics. In order to put all that data into one data set, we mapped how far each fire was from its nearest weather station, and then we only used weather data that was within a 10-mile radius of the fires. So we that condensed our data from about 1,600 fires down to about 350. We then took 7 years of monthly fire data, 7 years of monthly weather data, and we put that into the model in order to get 350 data point or rows of fire data and weather conditions, and 350 rows of weather conditions when no fires were present. This allowed the model to begin to predict whether a fire was the model began to predict whether a fire was likely to occur given the set of weather conditions, classifying it to 0 or 1. But really what the model was doing was associating a weather conditions with the presence of a fire and learning how to evaluate the risk of specific weather conditions. In order to do that, we created a neural network with a binary cross-entropy loss function and a sigmoid activation function, and 2 hidden layers. We used a batch size of 32 and 200 epochs. Once the model made its class predictions to find the hidden 0 to 1 risk assessment, we used model.predict_proba. With the architecture, let's look at the results. The overall accuracy of the model was 76%, but when the model was very confident in its ratings, either 0 to 10% for no fires or 90 to 100% for fires, it had more than 95% accuracy. And in terms of 10 to 20% and 80 to 90%, it had more than 85% accuracy. The model UI is a website, which we will link in the chat below. Right now, it's an ArcGIS model from last month's weather data. You can move around the map. You can look at it from a glance, or you can click on each point to find the exact fire risk. Currently, we have this color scale, but we plan to implement a brown to blue color scale for the colorblind. Finally, the GitHub is also linked below, where we have a link to the GIS and all of our files and documents if you'd like to take a look.
So we also have to take into account that there are some limitations with our model. The limited accuracy, which is mainly caused by the limited amount of data, including limited information about each fire and the weather at each location, and a limited number of fires in the data set. And we also have to take into consideration the ethics, because insurance companies may use our models to raise prices in areas where there's higher risk of wildfires. And in the future, we plan on doing more user research, especially with people on the West Coast, since they have more experience with wildfires. And we plan on adding more fires and more information about each fire to our data set. And we may also use satellite heat maps to track fires and expand our models to other states and countries where wildfires are prevalent, and add more features to the user interface. And one more thing that we may do is track risk of smoke, because wildfires may affect people living thousands of miles away from them. And we would like to say thank you to the Sure Start team and all the judges for making this project possible. Here are our sources. And we would like to open it up to any questions.